Hello higher chemistry students. Here we are, carboxylic acids, and again, a little bit of revision. So carboxylic acids, as you know, contain a carboxyl group, a COOH group. This group will always be on the end of a carbon chain, and we indicate we have a carboxylic acid by the oic acid ending and a prefix to follow. So for instance, methanoic acid, having one carbon atom in total, ethanoic acid, 2 carbon atoms in total, and so on and so on. We name our carboxylic acids by finding the longest continuous chain, starting with the carbon of the carboxyl group. That will always be carbon number 1. If there are any branches, they will take their position, like in the example of 3-methyl-butanoic acid. Please note, you do not have to systematically name carboxylic acids. Butan 1-oic acid will never exist because the carboxyl group is always carbon number 1, so we do not have to do that. Again, be careful and be logical when drawing carboxylic acids. These are the steps to help. Again, a little bit of revision from National 5. Carboxylic acids can undertake neutralization reactions when reacted with a base. There are 3 main bases that you should remember: metal hydroxides, otherwise known as alkalis, metal oxides, and metal carbonates. Bearing in mind, when an acid and base react together, they always form a salt and water. If it's a carbonate base that's used, you will additionally form carbon dioxide. You must be able to name the salt that is produced during the neutralization reaction. So for instance, if hydrochloric acid is used, you will form a chloride salt. If sulfuric acid is used, you will form a sulfate salt. And in the example given, if ethanoic acid is used, you form an ethanoate salt. Salts are named from the first part or metal part of the base added to the type of acid. So as shown, calcium oxide added to and reacting with ethanoic acid will produce the salt, calcium ethanoate, and water. And now over to you. Please try exercise C. Good luck.